Hi, welcome back to my channel, Peck Explains Physics. Okay, I'm Mr. Peck here. Today we are going to learn a new chapter called Electrostatics. Okay, Electrostatics is actually about charges. Okay, positive and negative charge. Yeah, as shown here, positive and negative charge. And the first subtopic in this chapter is called Coulomb's law. Okay, so what is about Coulomb's law? Coulomb's law explains about electrostatic force. Okay, in other words, Coulomb's law is about electrostatic force. Okay, and the formula for electrostatic force is kqq over r square. Okay, kqq over r square. So from this equation, you can see the electrostatic force is directly proportional to the product of charges, of both charges. That means the higher the charge, the higher the force. The higher the charge, the higher the force. But this force is inversely proportional to the square of distance between both charges. That means inversely proportional. We can say the nearer between these two charges, the smaller distance between the two charges, the higher the force. Okay, the higher the force. So that is the relationship. And kqq over r square can also be equal to kqq over 4 pi epsilon naught r square, because this k is the same as 1 over 4 pi epsilon naught. Okay, so what is actually k? K is called electrostatic constant. Electrostatic constant, which is the value 9 exponent 9. And this is the unit, Newton meter square per Coulomb square. Don't mistaken, even the constant value also have unit. How do you get this unit? You rearrange the formula, put the k in front, everything, the other variable, just put the other side, and then you can get the unit for k. Okay? And what is epsilon naught? Epsilon naught is called permittivity of free space. Permittivity of free space. So you must be careful. K and epsilon naught, they are two different constants. K is electrostatic constant. Epsilon naught is permittivity of free space. This permittivity of free space, the value is 8.85 exponent negative 12. And this is the unit. So both of these constant value, you can get this value from the list of constants provided. Okay, list of constants. So you can use either formula. Normally people use kqq over r square because it's simpler compared to qq over 4 pi epsilon naught r square. Okay, mostly people will use kqq over r square. Actually, if you still remember, in first semester, you learned about gravitation. So actually, we can draw an analogy between electrostatic and gravitation. So let me show you. Okay, this analogy. Yeah, this is the one. You see that? So actually, there is a huge similarity between gravitation and electrostatics. If you look at here, in gravitation, we already learned about gravitational force. We learned about gravitational field strength. We learned about gravitational potential energy, gravitational potential. So these things, we have similar terms in this chapter, electrostatic. So if we have gravitational force, now we have electrostatic force. Last time we have gravitational field strength. Now we have electric field strength. Last time we have gravitational potential energy. Now we have electric potential energy. Last time we have gravitational potential. Now we have electric potential. And somehow we have work done in gravitation. Now we have work done in electrostatic. So they have same terms And also the equations also the same. So if you still remember what you learned in gravitation, so you will find it easy to study this chapter in electrostatic because they have same equations and same terms. Okay, same terms you're going to learn. So, for example, like gravitational force, the formula is gmm over r square. Okay, gmm over r square. Electrostatic force is kqq over r square. So the difference is just the constant. Last time we used g, now we use k. And then last time we used mass. Okay, we have two masses. Now we have two charges. Last time we used mass, now we use charge. Okay, two charges. And distance between the mass, this is the distance between the mass, and this is the distance between the charges. You see, it's the same. Both are forces, so they have the same unit, Newton. But the difference is, in gravitation, we know that the forces between two masses must be attractive. Gravitational force can only attractive force. It's only attractive force. Two masses won't repel each other. It only attract each other. Okay, only attract each other. But in electrostatics, we have attractive force and also repulsive force. Depend on the sign of charges. We know that between same charge, positive and positive charge, they repel each other, isn't it? Repulsive force. But if opposite charge, positive and negative charge, they attract each other. They attract each other. Okay. So in electrostatic force, we have two kinds of forces, attractive and repulsive. And about the gravitational field strength, electric field strength, we're going to learn the next part. Okay, this is the thing. Okay, force is a vector. So vector has magnitude and direction. Okay, this is when the calculation, you ignore the sign on the charge. You must draw vector diagram and find the xy component. For direction, you must put a positive and negative sign to denote the direction. Okay, I will explain this later. Okay, let us go back to our Coulomb's law, electrostatic force. Okay, so the unit for electrostatic force is Newton. Okay, electrostatic force is Newton. Now, about direction. Yeah, let us learn about direction for electrostatic force. Okay, so the direction for electrostatic force depend on two charges. So for electrostatic force, you must look at two charge. Because even the equation, you see, the equation of force, it has two charge. The point charge and the test charge. QQ. You can write big Q, small q, or you also can write Q1, Q2. Q1, Q2. So you have point charge and test charge. So for force, you need to look at both charge, point charge and also test charge. What is point charge? What is test charge? I believe you learn about in gravitation, you learn about point mass and test mass. If you still remember the difference of point mass and test mass in gravitation, let's look back to the analogy. Okay, in gravitation, we have a point mass and test mass. What's the difference between point mass and test mass? If you still remember, in gravitation, point mass is the mass that provide the gravitational field. Test mass is the mass that inside the gravitational field of the point mass. I will explain this deeper in later part. Okay. So last time we have point mass and test mass. Now we also have point charge and test charge. Okay. So the only difference is last time we used mass, now we use charge. That's it. Okay. Okay, let us look back to later. I will explain what is point charge and test charge later on. Yeah. So you just stay tuned for my upcoming videos. Okay, I will explain one by one. Okay, so Force, electrostatic force, bear in mind, you must look at two charge, point charge and test charge. Okay, especially the direction. It depends on two charges, point charge and test charge. So for attractive force, okay, it is experienced by unlike charges. Unlike means opposite sign, positive and negative sign. So if you have two unlike charges, positive charge and negative charge, they have attractive force. They attract each other. Okay, positive and negative attract each other. They have attractive force. So this is the force towards each other. But if you have like charges means have same sign. Same sign. That means either is both positive or both negative. So for both positive and both negative, they repel each other. Repulsive force. Okay? Repulsive force for like charges. Positive and positive, negative with negative, they repel each other. Okay? So the force is away from each other. So you need to look at, so for electrostatic force, you need to look at both charge. If both charge have opposite sign, they attract each other. If both charge have same sign, they repel each other. That's it. Okay? And you know that for force, for electrostatic force, they are action-reaction force. That means these two forces, they are equal to each other. But opposite direction. I can write something here. So this force, actually they are action, reaction force. What is mean by action reaction force? Look back to your semester 1, chapter forces. What is mean by action reaction force? It means they have same magnitude but opposite direction. Even though, for example, even though if this is the first charge is only one column, positive one column, and the next charge is positive, maybe 100 column. What do you think these two forces will be? Will they have the same forces? Will they have the same forces? Yes. Both forces, they are calculated by the same formula. That means Q times Q. So they end up with the same value of force. So that means this force, if one column, if one column has the force of maybe 1000 Newton, so the 100 column also will experience the same amount of force, 1000 Newton. Okay, you cannot say, okay, one column is pushed by bigger force, but 100 column is pushed by smaller force. No, they have the same amount of force because they use the same formula, KQQ over R square. Okay, they are action reaction force. Action reaction force means what? Means they have the same magnitude but opposite direction. Opposite direction. That's it. They have the opposite direction. So if one is to the left, the other one, it must be to the right. Opposite direction. Okay? But same magnitude. 1000 Newton, 1000 Newton. Okay? And they must exist in pair. You cannot say this force is only experienced by the small q. The big Q also experience the same amount of force. So this electrostatic force, they exist in pairs. It won't just exist in single. Okay, they must exist in pairs. They are a pair of action-reaction force. Okay, now let us sketch the vector diagram for electrostatic force on charges. Okay, so we have an example of 4 charges here and see how they interact each other. Okay, Q1, Q2, Q3, Q4. Now let us start with the first one. Sketch the electric force on Q1. Yeah, actually, do you know that electrostatic force can also be called as electric force. Simple, yeah? Can also be called electric force. So it's the same. It's the same. You can say it is electrostatic force, or you can also say it as electric force. They are the same. Okay. Two names. We have two names. Okay. Now, let us sketch this diagram. Okay, shall we? Let us sketch this diagram. Now, sketch the electric force on Q1. On Q1 only. So how? So remember, for force, you need to look at both charge. Okay. If same sign, they repel each other. If opposite sign, they attract each other. Okay. Let us begin. So between Q1 and Q2, they are same sign. Same sign, so they repel each other. Okay. They are like charges. Like charges, they repel each other. So only draw the force on Q1. So remember, look at the questions. Don't draw all the forces on all charge. Don't draw force on all charge. Only draw the force on the charge it specifies. So like the first question, it only specify force on Q1. So you only draw the force on Q1. Don't go to draw force on Q2. Don't draw force on Q3 or Q4. Okay? So draw the force depend on the charge the question specify. So the first question is specify Q1. So only draw the forces on Q1. Okay? So now, so between Q1 and Q2, they will repel each other because same sign. So how to draw? Q1 and Q2 repel each other. So yeah, away. 1 and 2 repel. So this is F21. F21. This F21 means 2 on 1. The number behind is the one who experienced the force. Okay, 2 on 1. Now, how about between 1 and 3? 1 and 3, they are unlike charges. Opposite sign. Opposite sign, they attract each other. Opposite signs attract each other. So opposite sign attract each other. So yeah, attract. 1 is attracted to 3. So we can say this is F31. This is F31. Okay, F31. And then between 1 and 4, positive and negative, they're opposite sign. Opposite sign, they attract each other. Attract each other. That's it. F41. Do you see that? So these are the forces experienced by Q1. Okay? Now, the second question. Sketch the electric force on Q2. So on Q2, so look at one by one, yeah? So between 1 and 2, yeah, same sign. Same sign, they repel each other. Repel each other. Okay? Same sign, repel each other. So this is this is repel, being repelled. Okay, so this is what force? F12 or F21? Because the one who experienced this force is 2. So the number 2 must be at the behind. Yeah, behind subscript. So this is F12, 2 at behind. Okay, you understand that? F1 on 2. Yeah. Just remember, F1 F12 means F1. Okay, F12 means F1 on 2. Yeah, who give this force for 2 is the one who give this force on 2. 2 is the one who experience. Okay, let me show you. Okay, okay, come on. Yeah. So this one, sorry. Yeah. So this 2 is the one who experience the force. Yeah. 2 experience the force. Yeah. 1 who provide. Okay. 1 who provide. experience. One who provide the force. If what is F21? F21 means F2 on 1. F2 on 1, who experience a force? One who experience the force. So like F21, this one, Q1. So who experience F21? Who experience F21 is Q1. Q1, one who experience this force. Okay, F2 on 1. 2 exert on 1. 2 exert on 1. This F12 is 1 exert on 2. 1 exert on 2. Okay, so Q2 experience the F12. Yeah, the number behind, the number behind is the one who experience. The number behind is the one who experience the force. So this F12, so 2 is experience the force. Now, okay, let's talk about between 2 and 3. Between 2 and, just now already Q1 already, now Q3. Okay, between 2 and 3, opposite charge, opposite sign, unlike charge. So they attract each other. Okay, so attract each other. So attract each other. So this is F 3 on 2. 2 who experience. The number behind is the charge who experience the force. Okay, F3 2. Now how about between 2 and 4? 2 and 4, opposite sign. They attract each other. So between 2 and 4, they attract each other. So this is F42. 2 who experience the force. You see that? Yeah, very simple. Just show you. You see? This one Q1 means 1 who experience a force, 1 who experience a force, 1 who experience a force. This one 2 who experience a force, 2 who experience a force, 2 who experience a force. Okay, that's it. 4, 2. 4 and 2. Yeah, 4 and 2. Yeah. Opposite sign, attract. Okay, now let us sketch the electric force on 3. So between 1 and 3, opposite sign, they attract. Okay, between 1 and 3, okay, opposite sign. So this is F 1 3 or 3 1. 1 3 or 3 1. 3 who experience. So F13. Okay, between 2 and 3, also opposite sign. Attract. So attract. So this is F23. And between 3 and 4, same sign. Negative and negative. Repel. So repel. Very hard to draw. Yeah? Negative and negative repel. This is F for 3. Maybe you can write a small line here, just to show that it originates from 4. Yeah, like that. Yeah. And this one originate from 1. Originate from 2. That's it. Okay. So this is F for 3. So who experience all these forces? 1 3 2 3 4 3. It is the 3 charge 3 who experience a force. Charge 3. Okay. 1 1 1 2 2 2 3 3 3. Okay. Now how about sketch the electric force on 4? On 4. So let us draw. So between 1 and 4, opposite sign, different sign. So they attract. So this is F14 or F41. Yeah, F14. F1 4 because they 4 experience. Now between 2 and 4, also opposite sign. Opposite sign they attract. So this is F24. Okay, F24. Okay, and this is F24. F24, yeah? Is it? Yeah, it is F24, yes. Yeah, F24. Opposite sign they attract, F24. And then between, opposite sign they attract. Now, how about the 3 and 4? 3 and 4 is the same sign. Same sign, negative, negative. They repel. So repel. Repel away from each other. Repel. This is F. 3, 4. Who experience all these forces? 4. Charge 4 experience all these forces. Yeah, so the force must be behind. So now, let us draw some dotted line to show that the origin, the force origin, so that this force is between what charge and what charge. Okay, yeah. If you have ruler, better you use ruler. Okay, so these are the forces. Okay, so if the questions say draw the force on Q1, so you just draw all the force on Q1. Don't draw the force on other charge. On Q2, just draw the force on Q2. On Q3, just on the Q3. Q4, just on the Q4. Now, after the question asks you to sketch all these forces, the last question should ask you to find the resultant force. Ask you to find the resultant force. So to find the resultant force, it's the same as semester 1, chapter 1. Have you ever find resultant force? Of course, you must draw a vector diagram. So this is the vector diagram. You see that? This is the vector diagram. So what you need to do is you need to build a xy axis. You understand? You just need to build an xy. Just build an xy axis. Xy. Okay? Just build an xy axis. And then find the x component, find the y components, put into the tables. Yeah? Gather all the information into the table, and then find the Pythagoras theorem, find the resultant force, the magnitude of resultant force, use Pythagoras theorem. Yeah, Pythagoras theorem, the x squared plus y squared, you understand? And then you find the direction, tangent theta, y over x, square root, and then the angle is like covering. Okay, find the angle is above or below the positive x-axis, or is it negative x-axis? So find all these directions, which I will discuss in the problem solving, how to find the resultant force. Okay, drawing the vector diagram, find the components, x and y components, and then finally Pythagoras theorem and tangent theta to find the directions. Okay, we already learned all this in semester 1. So the difference now is just this is about electrostatic force. And the most important thing is you must draw the vector diagram correctly. It's all back to what? It's all back to same sign, repel, opposite sign, attract. Okay? And remember that electrostatic force must depend on two charge. Yeah, you must look at both charge, the point charge and the test charge. You must look at both charge. And the force experienced by both charge must be the same. No matter it is a big charge or small charge, both of them experience same magnitude of force. Okay, so that's about electrostatic force. So the next video going to discuss about electric field strength. Okay, thank you. Bye.